So let's take a look at what Lab 2 this week entails. Um, there is a common assets package. All right, downloaded this once before somewhere. Um, we've got a couple things. I've got some reference files, transform example, property example, vector example. They will show up. These are basically things that show up in. These are things that are going to show up in the slides. So, if you're so basically these are things. All right, let me go over. Let's look at what your assignment is. Okay. Basically create a new project. Just do a 3D. Create a new scene called Sandbox. This is where, and you will be using the common asset package. Make 3 folders in your asset folder: materials, prefab, scripts. I know I've got create 4 materials. You don't need to because the common asset package is there. I should update this. But basically, you've got moving cylinders. All right, you're going to make a move script. And basically that move script is going to have a public variable that we'll be able to edit in the editor. And you'll send these 3 cylinders off in different directions. And there's more in here about what we need to do. It'll be make more sense as we go forward when I actually do the scripting. Spinning box, you'll make a spin script. You'll have a vector 3 that controls what axes that it's going to spin on. You'll create 3 of them. They'll spin in different directions. And then we'll have an basically you'll have an orbiting sphere set. One object will be parented to another, and and there'll be an empty object for controlling how it orbits. And basically we're taking the spin script and applying it into a particular application here. And that will make sense when I get in, when we put the spin script in, when we get into Unity, this will make more sense. Create a script that changes the object scale over time. So we're talking about, so right now we're talking about the transform, which contains the location, its rotation, and its scale. So 2 are required. The scale is the 3rd that's not required. And then if you really want to go all out with the orbiting example, make a solar system. Now, this is circles, not ellipses. It's not mathematically or scientifically accurate, but it's just visually pleasing. Is what we're doing here. Is more what you should be thinking about. So this is, again, I'm showing you what you need to do, and then I'm going to show you how you're going to get there. This is going to be I'll do this a lot in several of these classes. I'm going to show you what the lab is, what you need to do, and then we'll go over how to get there, and how to achieve that. And I close Canvas. So let's go through these PowerPoint slides. So we'll start with. So what is a Unity script? Scripts are components that contain logic for a given game object. And that's the first thing. Scripts are components. Like transform is a component, like the properties for a light is a component. Which means, now this is what's important. Each component has a class. So you can actually ask for cameras. You can ask for camera components. You can ask for the light component. You can ask for. I'm trying to think what else. The render, the render mesh is another component. You can ask for these in code. Scripts are written in C sharp. They used to have JavaScript. That's now really that JavaScript is now gone. They also, once upon a time, there was a language called Boo. That's very gone. Basically, a few years ago, Unity basically said, there's only 3% of you not using C sharp. We're just going to use. So they went forward with C sharp only. Break down a script. Let me actually make. This will make more sense if I'm actually. Let's go to What's the question you guys having over there?
Just the fact that they're using the cube as their
6 sides of the cube.
yeah.
Wait.
Where's the 7 for the cube?
What are you guys talking about? That they put a 6 on the side of the cube?
Yes.
Yeah, they'll just put a 7 there.
Ah. Okay.
Yeah, you guys are overthinking it. Yeah, you guys are way overthinking that. All right, moving on. Again, I'm going to create a new scene. I'm going to do basic built-in because I'll have a main camera directional light. Again, I'll put in a cube. Object cube. And I'll make this 100 by 100. All right, I'm going to drag my common assets pack and I'm just going to bring it right into here. I might as well just go over what's in here right now, common assets. So you've got a set of crayon colors. So I'm actually use this for my grass. There's a set of gray materials going from almost black. It's not a perfect black, to like a very almost white. Not pure white, but close to it. And there's different levels of grays that you can play with. There is the pure materials, so pure black, pure blue. So pure. So this is pure black, cooler. So this is 0 across the boards. 1 in the blue channel, 1 in the red channel, 1 in the green channel, and these are variants of those with 1 and 2 of the channels. And then pure white is 1 across the board. So, and then you have a couple prefabs. Gray floor. I don't know why. So if you wanted to, these are all materials. There are 2 different player prefabs. So this is the prefab with using a mesh, and this one is using primitives. This is the one you'll use very often. So this is going to be your player. Say hello to player for a lot of assignments this term. All right. I'm going to. Where's this looking at? So what I'm going to do is I'm going to take my camera. I'm going to rotate it 90 degrees, so it points down. And I'm going to bring this. So basically, I'm going to be pointing straight down. All right. This is going to be sandbox. There we go. All right. So let's go back to assets. So they wanted to make a prefab, a material folder, and then finally create a scripts folder. And I'm actually going to create another folder here, call it Lab 2. We'll do all our work in Lab 2 here. All right, so there's 2 scripts that you have to create this week. It comes up as mono-behavioral script. I don't know why they changed this, but it was just basically C# script. And this basically is going to be spin. And the other one is going to be the move script.
What script?
Move and spin script. That's what the assignment. Yeah. So we'll start with the spin script. That's going to be We'll start with the spin script. Okay, so let's break down parts of a C# script file. All right. So basically, when oh wow, they've changed what comes in naturally with a script file. There is a package using system.collections. This may be useful later on. This will be using things out of this. But we'll start right now. There's using lines. This is at the top of the file. This is what packages we are using with this script file. So Unity Engine is a package of code pieces that are all related to the Unity Engine. So things such as, we go jump down to this here in the start area, we can type in lowercase game object. It knows what that is. Capital game object, which is the object. It knows these are Unity pieces that it knows, and it knows it because it's using the Unity package. So I want to point out that when you go lowercase game object, it refers to the object that the script is on.
So capital means everything else, but lowercase means itself.
So the lowercase g means that this is it's either a property or a variable. In this case, this is a property, and it's basically, again, it's the game object that the component, the game object this component is attached to. A component is always attached to a game object. Now, once we have access to the game object, we can access its transform. Now, we can do this with transform because every game object has a transform. Other types of components, there'll be another way to grab those components. And then from the transform, we can do its position, local position if we're looking at something that's parented. There is also rotation. Again, there's a local rotation, and then there's also a local scale. So scale of the transform relative to the game object's parent. For our purposes, there are functions. And for our purposes right now, we want to use what's called the rotate function. And it's looking for a vector 3 Euler. So what we're going to do, so basically these are different methods, or they're called functions. They're functions, but they're called, in the C# methodology, they're called methods. So one of the things is we can add variables to this class. And so one of the things we're going to do is at vector 3, will be our spin rate. And I'm going to do vector 3.0 just to make sure it's initialized with something. So that, and this is the way of thinking about this is that I'm going to set this to no rotation so that my designers or artists who are going to use this have to set something specifically and not be lazy. So I'm going to grab the spin rate, and it's going to be looking for that right here. And then we do need to terminate the code. So again, game object is the object we're on, specifically its transform component. And then from the transform, we're using a function called rotate, and we're going to use spin rate to update that. And this is not supposed to be in start, it should be in update. In fact, we won't need a start function for this class. So this is what your spin script should look like. It needs and we also need to make, so variables are by default are private, which means that they are hidden. They're not accessible outside of the class. By making it public, it makes it accessible outside of the class. It also makes it accessible in the editor. There is another way to do this, but this is the easier of the two ways right now. And we'll need to talk about what the other one is doing at another point. There's another way to do this, but let's just deal with public variable at the moment. Let me see. So we can jump back to Unity, and it's already compiled the script already. I do want to rename this to be floor. And then I'm going to create a 3D object, which will be another cube. And I'll put this at 1, 1, 1. I'm going to put the spin script on it. And I'm going to go to assets, common, and I'll use the purple on it. And I'm just basically duplicating them. So this one right here, I'm going to spin. I'm going to do 360.
I think you need to set it to the lower number. Like 20.
Okay. Oh, okay, I know what I've done wrong. We'll set this to, all right, the thing about the spin rate right here, we also need to multiply this by time.delta time. All right, what is time.delta time? Basically, it's the elapsed time. And by doing this, we are now being frame rate independent of what's going on. I am going to do 360 here. And by doing this, by adding the 360, basically I'm saying how many rotations. So I'm going to save that. And I'll do one rotation on the Y. I'm going to do this back to 0. All right, I'm going to go here. I'll do 1 on the X, and then I'll do X and Z. And you can see that I'm doing a single rotation every second with these guys. And this is the first thing that you should come across is that by providing your script different variable information, you can get different behavior out of your scripts.
So like that 360 would only turn like one value.
Oh, it would only turn one. Yeah, it would only turn one degree per second.
Yeah. Well, that's not smooth.
Don't Just follow along with class right now. I am recording the lecture, so don't worry.
Just observe.
So I'm just going to go over this right now. This is the line of code that needs to be written. 2 lines of code, basically, need to be written. All right. Let's go. I'm going to move on. What's nice here is that I can jump between scripts here in Visual Studio.
Oh.
So the move script. Now, we're going to start again. The first one that we're going to do is a public vector3 move rate. And this will be vector3.0. This is so that we're initializing it. I won't need a start function because I'm not doing anything this week. But all right. So the first thing that now the problem with the transform again we'll go do GameObject.transform position. And again, this is the world position we're talking about. The issue with this is that this is a property, and so you can't always get and set and do all that at the same time. So what we'll do is we'll do a vector 3. I'll just use loc. And then I'll do I'm missing the semicolon, line. So we'll do a GameObject transform dot position is equal to loc. So basically what we're doing is we're going to get it and then set it. And then in between here, so, and again, these 2 slashes makes a comment. So this is get value, change value, set value. Now, this week, we're only going to be writing 3 lines of code. The change portion is only 1 line of code. When it comes next week, I think it's next week, you'll be writing a bobbing script. And that will take up a lot more code. So, but ultimately, the change value here is going to be location plus equals. So this is location is equal to locate plus our move rate times time delta time. Now we could also do location plus equals these 2 lines of code are equivalent to each other. Basically, this is basically it's we're adding the value of this and this together and assigning it back. And here it's just doing it right, adding whatever this is, adding it to that. All right, I'm going to comment this line out because I don't want to do this twice. And we said we were doing cylinders, so 3D object cylinder.
Hold on. Do we have move rate already set somewhere?
No, you're going to set that in the editor.
Okay. In which case, would we need it public?
Dude, I saw I made it public. Yeah, I made it public.
Oh, you already set up move rate. Alright, sorry, I didn't see that. Sorry, my bad.
So we're gonna make this orange. So I'll have them move. This will move. What's assets scripts script. So I'll move this one down the z-axis, which is the forward direction. I'll do 10. I'll do 1. Let me get this real slow. I'll move this down the x-axis 2. I'll do -2. So go that in that direction. And this one I will have -1, -1. So it'll move off in that direction. So back to the game view. So as I advance, this one's going in that direction, this one's going in that direction, that's going in that direction. Again, this is the -x, positive z, -x, -z. So far, so good? All right. Go back to my scene view. All right, I'm going to make 3D object sphere. And I'll make this 3, and then I'm going to duplicate it. I'll make this 1, 1, 1. And then I'll go to my assets. I'll make this yellow, and I'll make this one brown, just so they contrast. Okay, so the issue here is that I'm actually going to create an empty object here, and that's going to be the root. We'll call it moon root. So this sphere right here is going to be the sun, and this is going to be the moon. All right, when I parent the moon to the moon root, it's going to keep its location. So it gave a position. It's all weird because it's the. I'll do 2. Don't worry. Moon is okay. Sun. Okay. So what we want is to have this object rotate around this object. We're basically going to with the moon root. Basically, this is where we're going to scripts. This is where we're going to apply the spin script. And we're going to do this around the y. Do this 0.5 just to go slower. So as we turn this around, this object is going to rotate around. Because this object's offset on its root, that's why it's going to give us that illusion of rotating around. So I need to grab this and I'm going to bring it in closer. I'm going to press play. There you go. You can see that it's rotating better. All right, what's your question?
Just so I understand exactly what's happening. The reason why the moon is rotating around the sun is because we have the moon root, which is like another visible object.
Yes. Yeah,
the moon
got
root rotates, which causes the moon to rotate. So we don't have to do this weird mixture of a rotate script and a move script on the moon
correct.
that measures its yada 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 yada. Right?
Correct. Yeah, we're not actually doing an orbit in terms of like the mathematical values. Like this is the velocity and this is the effect of gravity and all that baloney. This is not a math physics course yet.
Got it. We're just,
yeah.
Okay, got it.
This is obviously not solar system simulator that we're doing here. This is basically, again, I've shown you pretty much what you need to do. Let's talk about them in more specific detail. So again, we talk about the using statements. These are packages. Namespace and declaration and content. So this is optional Unity scripts. Basically, you can put your scripts in their own packages, and if to do so, you have to declare the namespace. So the next important thing is the class declaration, and that is this line right here. You will always see it be a public class. Move script is the name of the class, and that needs to this has to share the name of the file. And then all scripts in Unity inherit from mono behavior. Now we will use this to our later on we'll use this to our advantage. But ultimately, all scripts come from mono behavior. Why is it called mono behavior? Because once upon a time, Unity didn't use C#, didn't use Visual Studio. They used mono develop. It was an open source. Eventually, they ditched those external tools for Visual Studio. But the nomenclature of it being a mono behavior stuck. So this is the definition of the class. I collapsed it. And this is the opening brace of the class. Here's the ending brace of the class. So that's everything inside is part of the class. This variable is part of the class. This method is part of the class. So class contents, again, right now you're going to be adding variables and you'll be adding members. There are other things you can add to the class as well. You can add properties. There are other things that you'll add to classes as you go on. But right now you are writing either new methods or using methods or adding variables. The primitive variable types, so there are booleans, true or false, integers, a whole number, positive, negative, 0, floats, decimal, and for the most part, you're going to be using floats in your work. A decimal number, positive, negative, 0. Double, it's basically twice the size of a float, basically. Character, a single letter, and then a string, a set of characters, for example, words or a URL, and other things. Again, a character is a letter, a number, or symbols. So here are the literals. So when we talk about a literal, basically we're saying we're assigning this to be like a literal value to to it. Again, Boolean takes true or false, and this is the common way you'll use them anyways. Integers 0, 1, 3, negative 55, negative 9001. Doubles, and you'll see that here with floats. I've had to add an F to the end to those variables. And by doing so, I'm specifically saying that this is a float value as opposed to a double value. Characters, note the use of, sorry, but note the single quotes determine a character, double quotes indicate a string. Creating a variable, there's accessibility level, so private, you'll see it's either private, protected, or public. If you do not say an accessibility level, it's determined to be private by default. Protected is related to object inheritance, so we'll deal with that another time. And then the other one that you'll be using regularly is public. So we're making variables public so they can be editable in the editor. And again, there's another way to make them editable in the editor, but we'll deal with that in another lecture. Type, is it an integer? Is it a float? Is it a double? Vector 3s wasn't an integer. So it was a variable, but it's not of a primitive type. So not the float double booleans. They're I think it's a structure. Um, and so you'll deal with things. So vector threes are of the structure values. So you're dealing with them at value level. Um, you will deal with also there are your class types. I'm pointing them out because you will eventually start dealing with those. Those based when you're dealing with a class, you're dealing with a reference to the class itself, and we'll talk more about that later on. But in here, in this case, we've made a private integer variable called ammo count. We've assigned it to 1. And so, again, we've got the name, and then a value and assignment, and then line termination. Again, C# lines are terminated with a semicolon, which we can use to our benefit to write things out as need be. This one will assess the levels. Declare and initialization examples. And again, for primitive, you want to initialize those variables, particularly with structures like the vector3 or a vector2. You want to initialize those variables, like whether it's a vector1, basically it's 1 across the board, or a vector0, 0 across the board in that. So bool here's public bool is jibbable is equal to false. The int is int ammo count is equal to 1. Double private energy is 1.21, and there's gigawatts. It's a Back to the Future reference. Float protected drop chance is equal to 0.5. Character private character user letter A. String public string user greetings program, and that's a Tron reference if you don't know. And then there are class public game object bullet. Again, game object is a class, and we don't necessarily initialize it right away unless we are actually getting an object. So we'll look at actually these are what we're doing here is these would be how you would create the variables as part of a class. Now, when you're writing something local to a function, you wouldn't add the protection level. So again, class type variables. A class type holds an object, is an instance of class. The null is a value when no object is assigned to the variable. I should look up. Oh, this is hilarious. Okay, what's the difference between a null value and a 0 value? And this image will explain it really quickly. This is a 0 value. There's no toilet paper here whatsoever. There's just the holder. Here is the null value. There's not even anything here to reference. This is a null. This is the 0. There is no toilet paper. There's no toilet paper on this roll. The null value, there is no toilet paper whatsoever here. So, comments, single line comment, and there are block comments. Block comments can extend over multiple lines. So this is know the difference in use. If you're blocking off a lot of code at once, you'll use your block comment. For the most part, you will use single comment over and over. Your math operators add. It will also combine strings, so hello world. Subtracts, multiply, divides, modulus, returns the remainder of an integer division. Assignment operators, again, equal, assigns a value, add or subtracts, multiplies, divides by the value. And then the increments, the plus, plus, minus, minus. chance to use those yet. But all right. Two object representation. So in this case, we've got an empty game object. New empty game object created. Every game object has a transform component. So here it is in the world. And we will show an empty object like in a couple other slides. So this is the reference to other slides that are coming. So here is the empty game object. This is the name, and then the blue here is going to be its transform. Single object example. So here is the sphere. And in this case, the transform is blue. The sphere collider is going to be green. The pieces that these are going to be purple. The sphere, the mesh filter, mesh renderer. These are the visual components, purple. A rigid body, which is another component, going to be shown as yellow, and then the script is going to be blue. So this cyan, I should say. And again, we can show them listed out vertically, horizontally. Here's the capsule example. So this is showing, so in this case, this cube is parented to the capsule, and this capsule is parented to player one. This is not how the prefab is given to you. Capsule and cube are at the same level, unfortunately. Well, I'll explain why later on. But going on, here's player one. Player one has basically it's transformed, has a rigid body, has a script component. Whereas capsule has basically visual and collider. Visual and collider. So go through the transform. Overload. Here we go. So component scripting, transform components. So dot operator. So this is basically when you have access to a member of something, you're going to use the dot operator. So again, game object had a property that got the transform. So we did game object dot transform. Can you use with the namespace to access its contents? Using the dot operator in Visual Studio brings up IntelliSense. This is huge. It's a tool that will help you see what is available to you, what is part of that class. This is a huge, huge tool that will make your life so much easier. What are members? Fields, constants. This is basically variables that are not going to change. Methods, aka functions, properties, special access methods used to get or set values. There are other members. You can read more of them in MSDN. And you can go dot after dot dot. So game object has a property of transform, which we can get, and transform has a property of position. So game object dot transform, we put in parentheses dot position. We can do a transform reference. So 3 ways a property can use. You can get, you can set, you can use both. But it's not always used to do both in the same line of code. Visual Studio will yell at you and tell you that you can't do stuff occasionally because you're trying to do both. You're trying to set and get at the same time, and it's confused. That's why we set out to get the value, changed it, and then put the value when we wanted to change back into the property. You can do the following. It's not always, so this is not always possible to transform that position plus equals vector 1. Again, what is the again? Get it, process it, set it. Again, we're only doing one line of code of processing right now, but ultimately, like you'll be writing bigger scripts with multiple lines of processing. The dot operator will let you see members. It will bring up lists, also a type of bit to reduce. You can also type a bit to reduce the list size of what's there. You can use the arrow keys to move up and down. You can also hit return to autocomplete. You can put your cursor over more of the information. And then as you're typing something, if you want to get back to IntelliSense, just delete back to the dot, hit dot again, it'll bring up IntelliSense for you. So vector 3, this is basically has an X, Y, and Z. And it's a float X, float Y, float Z member. Vector 3 code example. So here is vector variable, vector 3.0, and I set the X, Y, and Z, and I put it out. So this is, you'll see in the console window. Two common vectors you hear about, we're going to briefly go through them, but we'll go into more vectors in a future lecture. Vector addition, so vector plus vector is equal to a vector. So 1, 2, 3 plus 4, 5, 6 is equal to 5, 7, 8. What we're using is finding a new position based on the amount we want to move. And there's a vector multiplication. So 1, 2, 3, 4 times 4 gives us 4, 8, 12. Use it scaling a direction by movement rate, scaling a movement direction by time. So again, we set a move vector, and then we multiply it by times the delta time to make it frame independent. So the transform components, every object has a transform, and contains the object's position, rotation, and scale. We can store reference or transform in a variable. So like we can create a transform.transf. And there's other variables we could be saying here. Transform from a component. Every component has a class that defines it, and variables are created with a type of class. So we can do transform is equal to transf, game object.trans. Number 2 is more typical of what I would expect you to do. This will, in theory, give you the gamed object transform, but this is specifically asking us for the transform. Notice the lowercase t in transform to denote a property, so t transform is lowercase t. And I'm showing you the get component here, and this is a get component transform, get component game object get. And again, number 4 is preferred over number 3 because it would be very specific. My game object, get the component of the transform that's on it. Now, you won't need to do this specifically for transforms, but let's say like rigid body or another script type. Let's say we're dealing something with the camera. Mesh renderer is another one. So you'd use the get component for all of those. So get component is a generic function. You notice right here this bracketed area, and we ask for a class type. So it's going to get the type of the class there. So you'll see that on a regular basis soon. Yeah, sometimes writing your code with a little bit of paranoia creates better code, except writing secure code, then it's full-blown. Yeah, when you're trying to write secure code, basically anything over the network, then it's full-blown paranoia because you can't trust what's coming from you from over the network. So, just giving you a little bit of paranoia in your code creates better code. So position. This is a property of the transform. Transform.position. Stored as a vector 3. There is a translate function, but the problem with the translate function is that it is relative to how the object is rotated. time delta time. Again, this is the variable time. Delta time is the variable of how much is elapsed since the last frame. We're looking at rotation again. So underneath the hood, a rotation is stored as what's called a quaternion. It is a XYZ vector, which is the object's forward direction, and then a W, which is a roll around that vector. And if it sounds complicated, because it is. It's vector math. You are more used to Euler, what's called Euler angles, XYZ angles corresponding to roll, pitch, yaw. Basically, quaternions are really fast to calculate, and they're pretty much the standard in the industry at this point. We know how to translate from a Euler back to a quaternion, and quaternion back to a Euler. So, again, rotation unity, the yaw, what you're usually expecting, is the Y. Roll is Z, and pitch is an X. Transform that Euler angles, transform that rotation. Euler angles using that Euler angle problem is a vector 3 using yaw, pitch, roll, and then if you do rotation, you're getting the quaternion. Now, if you're not setting the quaternion out of the gate, you can grab it into a variable and then set the rotation right back with the quaternion again. Again, rotation, it takes a set of 3 floats, x, y, and z, or a vector 3. So it takes the Euler angle. That's why we used it. And don't forget, use dot delta time to rotate smoothly independent of the frame rate. Scale. And unlike scale position, you can only scale the object only using the transform local scale property. You'll assign a vector 3 that represents the scale for the axis. Uniform scale will have all 3 axes the same value. So whatever the value, like we'd say with scale value of 5, then we'll multiply by vector 1, so we'll have a vector of 5, 5, 5. Okay. Local means you're affecting the specific property of the object relative to its parent, if it has one. If the object has no parent, then you'll be affecting the world value anyways. Children of the object are affected as well as the change. There is a property for local scale, local rotation, local Euler angles, and local position. And then I've got documents here. Okay. So here is the get transform examples, the property example. So there's code here for you to take a look at if you want to dig into. I think that's everything I need to go over. All right. Any questions about this week's lab? Yes.
It says here the due date's by September 18th, is that correct?
Let me look at the due dates. Why is September 18th? No, that's a mistake. That should be September 11th next week. So I'll have to check other assignments.
Go back to it being the 18th?
What was that?
Can we go back to it being the 18th?
No. No, we need to move on. If you're still on this lab on the 18th, you're very far behind. So I gotta keep pushing you week by week by week. I have to go check what I did for the other labs now. Other questions? Say again?
The video for your lecture will be uploaded soon?
Yeah, it'll be loaded. I'm still recording, so I haven't. So once I'm done recording, I'll be uploading it. So yeah, and I did plug in the microphone this time.
Yeah, because the other one's
check a look what's going on. Shouldn't be processed. It should be fine now. Yeah, I uploaded that a few hours ago. So, any other question?
Yeah, quick question. Is there a point in using the trans or assigning our transform to the transf variable?
This week you don't need to do that this week. I had made a point of using that, but basically, like what we're saying is that the transform we can create a variable of the type of transform
Okay,
and then
I got
assign it,
you. Yeah.
and then use that as we see fit.
Okay.
Right, you don't need to do that this week, but there will be times later on. This is more showing you that you can do that, so that later on you can, if you want to, you can store a transform.
Or store anything else, right?
Yeah.
Okay, I got you.
Question.
Are we uploading a zip again?
Yeah, this is you're uploading your project
So same thing
as last week. Yeah.
okay.
Question.
I'm on the link that you gave us, but I'm not quite sure how to download Unity 6. Is there just something?
Okay. So the thing with let's go over it one more time. So let's go to the announcements.
Okay.
All right. So you're gonna open up blank Unity. Oh, come on. Hold on, I gotta edit it because it didn't. Okay. Save. Don't save. I don't mean to send it again. Okay. So when you reload the announcement, now it has a link actually there. So we'll click on the link, and then it brings you to this GitHub page. The green code button. Download zip.
Download zip. Okay.
Okay. So we're gonna make room here so I can see.
You wanna
I'm gonna
follow it?
pull the project right here, and then here is the zip folder. And this is the folder inside this. So I open up the zip. This brought up this window. I'm gonna take this project folder right here, and that this one is a new solution. I probably have this on the desktop somewhere else. But basically, here is the project folder. So put that in your working folder, and then go and open that with GitHub, not GitHub, Unity Hub. All right. The purpose of this is that if you don't have 6.0.16 F1 installed on your machine, grab this project, bring it home to your machine, put it on the machine, open the project, because when it tries to what it's gonna do is basically it's gonna say, you don't have this version of Unity. Would you like to install it? And that's what you want to do.
Okay. I think I get it. All right. So I want to open up Unity Hub.
You probably have Unity. It's probably installed. You probably have the correct version already on your machine. Go look at installs.
Open installs.
Yep.
No. Just
No.
2022.
Okay. Then now try open the project.
Okay. So
All right.
I open up.
All right. Yeah. Open the folder.
Open the folder.
That yes. All right. I'm gonna move on.
Okay.
Any other questions? Question.
Can you show us how to upload our project as a zip?
That's simple. Just unzip up your project and submit it to Canvas.
Oh, here.
Yeah. Right click. Yeah. Windows. Right click. From in here, we can go right click and show an explorer. And here is my assets. Here is the project itself. So here is the folder for that project. So basically, right click right here and send to a compressed. Now do this after you've closed both Visual Studio and Unity, please. It's going to complain. I'm not going to do it right now because it will complain because there are files active there are files that are in use that it can't access properly, and it's just that's Windows for you. So again, make sure you close Unity and Visual Studio before you Any other questions? Okay, I'm going to stop the recording at